Alright, so let's go ahead and take a look at how we do these when we have a closed interval. Closed interval means that they give us an actual section we are allowed to look at. So in this case, you'll notice the terminology is slightly different. Instead of finding a local maximum or minimum, they sometimes ask for an absolute maximum or absolute minimum. So that means we want the absolute highest value on the graph and the absolute lowest value on the graph. And because we have a closed interval, it's very important to test the outside function or the outside values to see where we're at. So if you take a look at the notes, the steps are the same. Find the critical numbers and use the first derivative test. Then it says determine the x values of where the absolute maximum value occur by finding relative maximums and endpoints on the interval that could be where the absolute maximum occurs. What that really is saying is plug in your x values and find out which one is the highest maximum. So these are mixed together. And the last two steps are the same thing, but you're going to find the minimum values. So just to give you a picture of what this looks like, we see this graph right here. And it says find the absolute extrema on -2 to 5. So if we find -2 and 5, we see -2's point is right here. And we see 5's point is right here. So what that means is we are not allowed to look at anything outside of those 2 points, right? So it says the absolute minimum value. We notice our minimum happens right here. The value is at -4. And this happens when x is equal to 3. Okay. The next question says find the absolute maximum value. Well, we see our absolute maximum value happens up here, which is at 4. And what you'll notice is it actually happens over here as well. So this happens at 2x values. The highest point is 4. The first time it happens is at -1, and the second time it happens is at 5. Let's try another one. It says find the absolute extrema on -5, 5. So I'll make this a little bit bigger. Once again, we mark -5, which is right here, and we mark +5, which is down here. So I am not allowed to look at this section since it's not part of our interval. I want our minimum value. Well, our absolute minimum value happens right here at -16. And this happens when x is equal to 5, because 5 is our value right there. Our maximum value, our highest point, happens right up here. We see the value is at 7, and this happens when x is equal to 2. So graphically, this is actually pretty easy. You're just looking for the highest point and the lowest point. What's a little more difficult is finding these using functions. So here's an example of one of the problems. It says find the absolute maximum and minimum values of the function on the interval and their corresponding values. So like always, I find our derivative and our critical points. F prime of x is equal to 2x to the third minus 8x what we're going to do is factor out a 2x. That leaves me x squared minus 4. And I'm going to factor again. So 2x times x plus 2 times x minus 2. Sorry, my stylus is lagging. That gives us 3 factors, our 3 critical numbers, which are x equals 0, -2, and 2. Now, before we continue with our number line, we have to make sure that we are within our interval. Our interval is -3 up until +1. So as you can see, this works and this works. However, our +2 is outside the range, so we're not allowed to use that number. So our next step is to make sure we use our number line. So in our number line, I'm only allowed to use 2 of these critical points. The first point is 0. I'm sorry, not 0. Our lesser value is -2. Our next point is 0. And because I have an interval, I have to make sure I stay between -3 and 1. Alright, so the nice thing is we are allowed to use our endpoints in this function right here. So if I were to plug in -3 into here, I get a negative number, I get a negative number, and I get a negative number. 3 negatives gives us negative values, right? Let's use a test point of -1 in this section. If I plug in -1, I get a negative number. Here I get a positive number. Here I get a negative number, which gives me negative times positive times negative. That's positive in this section right here. And then in this, I can plug in 1 since it is out in that section. We get a positive, we get a positive, and then we get a negative, which gives us this right here. So what we see is we are decreasing to increasing to decreasing. So what we have to do is we have to make sure we find our absolute maximum and minimum values. So what we do know is there are 2 places where there's a minimum. There's a possible minimum right here. And there's also a possible minimum right here. So the first thing I want to do is test these out into the original to see what our answers are. So we get f of -2 is equal to 1/2 times -2 to the 4th, which gives us 16, minus 4 times -2 squared, which is 4. That gives us 8 minus 16, which gives us a -8. Right? We also test out our minimum at f of 1. So f of 1 gives us 1/2 times 1 minus 4 times 1, and that gives us 1/2 minus 4, and that's equal to -7/2. So taking a look at, odd, -7/2. So taking a look at this, what we see is, actually let me fix this. Our absolute minimum happens here. So we know our minimum is -8 at x is equal to -2, since this is our absolute minimum. To find our maximum, we find our other 2 values, and so in this case, we see that this up here is a maximum at -3, and this right here is also a maximum, but I have to find which one is the absolute maximum. So f of -3 is equal to 1/2 times negative 3 to the third is negative 27 minus 4 times negative 3 squared is 9. That gives us I'm sorry, 333. I apologize. This was to the fourth. So instead of negative 27, this should actually be positive 81. So let's scratch this out and do this over. We get 1/2 times 81 minus 4 times 9, which is 36. That gives us 81 over 2, and I'm going to already do our common denominator, so that gives me 72 over 2, and this is equal to 9 over 2. If I plug in 0, I end up with 0. So of these two values, this is the higher value, so we know our maximum is at 9/2 at x is equal to negative 3. Alright? So the only addition here is making sure you test your endpoints to see which one has the highest value or the lowest value. Thank you.